Okay, well, it is midnight Eastern time. My carriage is being transformed in a pumpkin, and I hope I'm not losing any shoes. But I guess in the meantime, we can do computing in the network. And so good morning to people or good night to others. This is, again, computing in the network. The three chairs are here. Jeffrey here from the wonderful university, City University in Hong Kong. From Intel, and me currently in Montreal, Concordia University. Next slide. So you can connect to us in many wonderful ways. Obviously, we have all the meeting material on the data tracker, and you can get it from there. There's a Netherpad. There's the Jabber. We still don't have anybody to take notes, but unless we have that, then the next few seconds in any way we can take notes from the recording, because all sessions are being recorded. So please, everybody, and I think everybody's doing it, video is off, keep yourself muted unless you're speaking. And there is actually, there's a chat and there's the queue. And there's a Slack channel that I created if anybody likes Slack, which is also pretty much used. Next slide. So this is the usual intellectual property. If anybody who is presenting something today, especially people from industry, please make sure that you are very much aware that you must disclose your IPR. And I think the big thing here is a timely manner, because in other research groups, we had problems with the timing. Next slide. This is also the privacy and the code of conduct. Obviously, everybody is expected to be respectful and not harass people or do anything that people could think could be harassment. So this is obviously being good citizen, and in that case, good netizens. Next. We have to remind a lot of people also that this is the IETF. This is not a standards development organization. We have a mandate of conducting research, of fostering research. And I think as the chair also of another research group and this one, we have to remind, I think, especially draft writers that when they write a draft, it is not about something that will become a standard, but something that should highlight what is the related research and why the research community should be aware of this work. Next slide. So Coin, who are we? I think I will take just a few more seconds than I usually take on this slide because of a previous meeting that happened yesterday for some of you, and I think it's yesterday now for me, and probably earlier today for others. Our goal is to foster research in computing in the network. And what does it mean? That's what I think is getting to be interesting. Our scope is pretty wide, and we put architectures and protocols and obviously real-world use cases, application, and work in progress. And again, this is research in architecture, research in protocol, and research in use cases. For those of you who did not have a 20-hour day or had time to sleep in the middle, there was this morning well, I guess it was yesterday by now, a meeting, a side meeting on something that was called FIPE, which is Future Internet Protocol Evolution. And it made me understand, because we were cited in that meeting, it made me understand that a lot of people did not really understand what we were about. So let me take just a few seconds for that. We are about adding computation in network nodes. We're not doing P4. We had hackathons on P4 because P4 is one way to put computation in some network nodes, but P4 is not everything. We're not about switches. Somebody this morning in in the chat, but well, these people are looking at programmable switches. Yes and no. We're about research in the network, which is a distributed computer board. And this computer board has computing units and storage units, and these units are connected by communication means. This also gives us an incredible amount of potential uses, and that's where the research becomes so interesting. Those of you who were at SIGCOMM and those of you who were at ICN the conferences this year could see that there was an awful lot of research on this potential use of this distributed computer board, and routing, which will be presented, Sharon is on now, is one of these applications. This is in the network of the computing in the network. But there is also, and I don't know if Lars on, but Lars and Dave Oren have raised the issue that we could also be doing computing on the network. So once we're done filtering packets and routing them, we may be wanting to do more with them or to process them further for applications in IoT and AR, VR. So we're computing in the network layer and on the network layer. Because we do that, it also means that we need addressing and we need discovery. And this is also application in some of the semantic routing that was discussed in the previous meeting. And so it means all this discovery work that was going to be presented and goes way beyond the original intent of some of the computing in network, which was basically for data centers. So it goes into also loads in machine learning and things like that. This morning when I was listening to the presentations, it made me even think back in my old days when I was an architect in teledesic, which was the internet in the sky. And for a long time, we had thought that teledesic was the computing in the sky, because we needed a lot of onboard processing to compute the routes and compute all the things that we needed there. So this was also computing in the network, but in that case, the network is really above our hair. So we welcome the research that is related to some of the issues that were presented this morning in our use cases, in our applications, in the work in progress. We welcome presentations, and it made us think also, after listening to this morning's presentation, that today we have an awfully loaded schedule with as Jeffrey's going to present 9 presentations, but that maybe when we have our interim, sometimes in February, we could have a longer interim and actually really focus on research presentation this time, and the people from FIPE, you're more than welcome to present. So I think because of what I just said, I will probably take onto me to update the description of the working group on the data tracker to make sure that there's no assumptions about what we do that is something that we're not doing. So this was my spiel, and I will let it to Jeffrey to introduce the agenda and our growing number of drafts.
Okay, so we will take a quick look at current drafts and milestones before the presentation. Then the presentation will start from a use case AI at the edge. Then Dirk will introduce their direction draft, which has been accepted as our working research group document after last meeting. Then Eve will introduce the data discovery and discussion. This is following the discussion in the last meeting as well, also in the mailing list. Then after that, so Ike or Dirk Charlson will introduce another research group document, the use case. They have evolved from industrial use case to a more general. Then there's some updates for the no. So there's another presentation. So that's from a draft initially proposed to TSG working group, but they addressed one use cases. So explicitly mentioned in that draft that there's related to coins use cases. So so they will introduce this draft briefly. So in the part related to us. So then there will be some updates for the transport document and the application-centric microservice and the security. And finally, so Phil will introduce their new European project, which is related to us as well. So after that, hope we can have some time to discuss the future plans. Next, please. Yes, so this is a current draft. So we have two candidate research group documents. The use cases not specific to industrial, not more general. And then the second is the cautious direction. So we hope these two research group document can contain the insights or discussions in this group. Then there are several drafts will be present here today. And next slide. Yes,
before you go, Jeffrey, go before again. I think we had gone to the list about those two RG documents, and since we had no comment about not accepting them, I think we can consider that they are accepted. So I guess we can move on to those two, and then look at the others.
Yeah. Okay. So these are drafts not presented today, including some new drafts coming after last meeting from the second one and the third one. Okay, maybe we will address that later. Okay, next. So this is milestones. So for the state of the art and the challenges, maybe we have at least partially addressed in the direction document. But we need more contribution about the requirement and the implication for the network elements. And for the use cases, we now have the use case research group document, and we can discuss further on that. And okay, so as for the scope, as Jose and others, we have discussed this a little bit, right? We can continue this discussion about the scope of this research group. If you have any suggestions for the milestones, please let us know.
And I think the intent of the February interim is really to focus not just on research, but also on scope. Okay?
Yeah.
All right. So I think that's it. I guess I should stop sharing if I can. And our first presenter is Sharon, who will be speaking about the IETF Lisp virtual routing for AI at the edge presentation.
Yes, hi Eve, good morning. Can you hear me?
Yes, we can.
That's good. Can you share my slides so I don't mess up your setup?
Oh, sure. Okay. I guess I have to go back to the sharing. Okay. No worries. That was exactly why I queued things up. I'll share my entire screen. Here we go. I think this is you. Yes?
Yeah.
And let me just put this into presentation mode. Okay.
Okay. It was there.
Do you see it?
You said you clicked on stop sharing by mistake.
Oh, what I meant to do was to click on to hide the screen sharing. Sorry. Let's quickly do that again.
Okay. All right. Meanwhile, I'll just start talking, I guess. I'm going to present the use of virtual routing to help coin use cases, specifically Edge AI. So this is mostly informational because it shows how to use existing hard standards implemented already in software and hardware in a certain way to help Edge AI use cases. I think it's been a very edgy IETF all around, so there's a lot of interest, hopefully, and maybe this can help. So basically, basically AI is about taking raw data and turning it into insights. There's a lot of compute involved, mostly multiplying matrices and solving equations, and it requires a very high level of concurrency. Today, mostly we do that in the data center using leveraging significantly the spine leaf architecture to gather workloads and maximize concurrency this way. And that is fine using EMR, Databricks, Spark. And we should concentrate when we can, but then we have to distribute when we have to. And that's when we want to push Edge AI to the edge. This mostly has to do with situations where the SLA is sub-second. So if you think of the data center as the brain, you can think about things. The edge is more like the spine. You have to react immediately but intelligently. The load of the raw data is too heavy for me to bring in a timely manner to the data center. That's another situation where I have to push AI to the edge. Or when there's a commercial or regulatory situation where I have to run in a carrier in an edge premise, or in a car OEM premise, or in a municipal premise, or because I want to pull AI compute out of the appliances in the field as much as I can for the same exact approach, concentrate as much as I can. So I will pull as much AI as I can from cars because of updates, because of cost, because of idle time, but I cannot push it all the way up to the cloud. All right, next slide, please. Okay, so we want to push things AI to the edge, but we don't have the data center mechanisms that are available to us, and we need to find alternatives. And we're going to examine these alternatives based on virtual routing by two use cases on production networks that fit both. I'm sorry. Can somebody mute?
Yeah, somebody is typing loudly and there's background noise.
Yeah. Okay, so I'm going to use two production networks that hit all of these checkpoints: volume of raw data, response time, the cost of compute, and constraints that must be pushed to the edge. So one of them is mobility networks and car auto big data, information gathered by cars as they drive by vision and sensory. And next slide, please. The other example is cyber, where switches, terabit switches are sampled at gigabit rates and generate alerts and visibility for attacks using AI. All right, So next slide, please. I'm going to have 3 slides on virtual routing. There's not enough time to deep dive into it. So if any double clicking can be done in offline or in the working group which are relevant. So just virtual routing 101. Everybody knows SD1, VXLAN. The ability to run a logical address space on top of the topological address space is very useful for hosting enterprises on data centers, for hybrid clouds, and so on. And the basic idea is if AAA is a logical address and it wants to talk to BBB, then that logically addressed packet is encapsulated inside a topologically addressed tunnel between 1.2 and 1.3, and this is how traffic gets from AAA to BBB. So the basic virtual routing standards tell us how to encapsulate. There's a few ways, but they don't tell us how does the router 1.2 know that BBB is behind 1.3. The reason they don't is you could claim that an overlay network is just another network, and you could use any routing protocol of your choice, if you like vector path or link state or whatever. And next slide, please. So Lisp takes an extra step beyond these basics. The claim here is that if I'm going to apply topological routing in the logical network, then I'm going to have topological constraints on my logical addresses. I'm going to have route peering, which is a constraint. I'm going to have subnetting, which is a topological constraint. And Lisp notion here is that I can use an overlay routing for the overlay and underlay routing for the underlay. And the overlay routing idea is quite simple. Actually, if there is an overlay, there must be an underlay. Therefore, I can scale a mapping system between logical address and topological location. This is going to be key for AI Edge because we're going to use logical addresses as data indexes. We're going to address raw data using logical addresses to these kill zones where the data is going to be reduced to insights based on that sourced routing. So a few Lisp concepts here, like really quick. EAD is the logical address, RLOC is the topological address, XTR is an ingress-egress tunnel router, and RTR is what we use here, which is a retunneling router, which is if AAA is on Verizon and BBB is on AT&T, this will still work. Okay, next slide, please. And this is the last slide on virtual routing, and then jump to examples. If I have a mapping system, then I can define a multicast scheme, which is different than what we know from PIM and MBone, which is more like TV kind of multicast, where you have thousands of channels to millions of people. If I use a mapping system, then MLDs from AAA subscribing to S, source BBB, theme XYZ, the MLD will stop at the tunnel router, and he will register himself as subscribed to these feeds. So when BBB will send a packet to RTR 1.3, it will look up, okay, which RTRs are subscribed on behalf of the peers behind them, will replicate to them, and these RTRs in turn will replicate to those clients. So this is very useful for what we're going to do with edge reduction, because this allows us to have millions of channels for thousands of endpoints, and this will be a very effective publish subscribe for reductions. All right, so let's take a look at how this works. Next slide, please. Here is example 1. I have sampling of terabit switches in 0.1%, meaning every second I'm going to scoop thousands out of millions of tuples, and I'm going to steer them right at the source or close to the source to EIDs, which are 5-tuple masks. So if in every sampling cycles, in every switch, I'll pick up some tuples, then I will still steer them to one location which keeps tracks of this 5-tuple mask, or these bunch of flows, or one flow, depending on how I divide this thing. So that means I can calculate the distribution, the Bayesian distribution of the flow, and I can predict what it's going to be. I can create visibility to the entire traffic, even though I'm just sampling a fraction of the traffic and I'm tangent to the network without any inline components. And when the flow surprises me, then I can raise the alerts. So this has been very effective to put on top of existing situation or existing protections, and this mechanism, which is, as I said, tangent, was able to detect DDoS like a minute before a firewall.
Sharon, you're almost out of time. Can you advance?
So, yes. So I'll just skip. This shows you the reduction. This shows you the pattern. Raw data is sourced to context and then reduced to feeds. And last slide. Next slide. Next slide.
Yeah.
Next
okay.
And this is the last slide. No.
One more?
No, back one. Yes. Okay. The second production example is when cars drive around, they steer images to tiles of the earth which have an IP address, an EID, and that EID is calculating the state. It's calculating changes in, it aggregates detections, and it creates a feed for other cars of what's going on in this exact location. So the rest is, I think, self-explanatory of what kind of AI is done, how does it reduce the data, what is the data reduction. You can take a look at it yourself, and if there's any questions, I'll be happy to go offline. Homography, dbScan, simplexing. I think the important point here is that this method of achieving concurrency at the edge is based on existing standard, existing hardware that performs the load balancing, the security at wire speed, and it's very practical to leverage going forward in this direction. That's it.
Thank you.
Thank you so much.
All right.
Are there any questions? I don't see any hands. I don't see any chat. However, I will have a very quick question while the next people line up their slides if they want to.
Oh, does somebody want me to display? Or do they want to display themselves?
I don't know, Jorg and Dirk, Kushner, you're next. However, Sharon, I do have a question. How do you see the future of this into Coin? Will you submit a new draft? It's related a little bit to the draft that was started that was looking at AI and computing the network and AI. We can take the discussion to the list if you want, but it would be nice if you could, think about how you want this to evolve in this group.
Okay, that's a great question. So throughout this, when I first developed it for mobility, my goal was to invent as little as possible. So that's why I took the existing overlay standards and specifically the existing Lisp standard. So now, from what we observe after multiple production networks and use cases, is that what changes between use cases is what is the addressable space? Meaning, giving a problem, how do you divide it naturally so that it's algorithmically can be source routed to achieve distribution and parallel processing? And then what else changes, of course, is the reduction functions, which are domain specific, and what else can we support. So the next step will be to generalize, but keep it informational. So it would allow you to take a family of problems that can be naturally pre-partitioned to an addressable space. and that space after reduction can be subscribed in scale by applications, databases, the next step of processing.
Okay. We can also have some of that discussion online. Thank you very much for your participation, and it was great to see, you know, a different type of computing in the network here. Next presentation is Dirk.
Dirk and Jörg. Do you guys want to present, or shall I present?
Oh, actually, it's already there. Here's Dirk with video. Wow.
Yeah, so I'm trying to think. You have to admit me that I can present, I think.
Do we have to?
Yes.
Yes, but I think you have to request.
If it doesn't work,
there you go. I granted it. I granted it. Hopefully it'll respond. We can see. Are you seeing my screen still? Yeah, you are.
I think so.
Okay. But maybe what it is that I have to stop sharing. I think that's what the issue is. I think that's what I heard. Okay, sorry to delay things here. And now you should be able to, yeah, that's what it is. So in the future, we have to undisplay, and then others can be granted.
How's that?
Perfect. Looks good.
Okay. Okay, thanks. Yeah, good morning, everybody, or thanks for staying awake for so long. Okay, so this is an update on the joint work with Jörg and Timo on coin directions. So the intention of this draft was to describe for the group essentially, or summarize basically our intentions. So why are we doing this? What do we mean by in, or what, as Marie-José earlier mentioned, on network computing. So kind of trying to characterize the most significant ways of conceiving this. So presenting some thoughts. So so at what say layers, or say also levels of complexity can you think about computing in that context, and also trying to lay out the research landscape. So what are actually interesting questions that we could look into in Coin. And so the draft so far is say roughly structured like this. So we are introducing different types of network computing systems. We kind of collected some useful terms, trying to differentiate ourselves, and so characterize computing in network versus packet processing network computing. So talk about a few examples from maybe different points in this overall landscapes, and then we have a list, so it's still growing, of research challenges. Quickly on the updates, so thanks for adopting this as a research group item. Thanks very much, Xavier, for the feedback on the list. So we are currently working on this for the next revision. In the meantime, we also had additional discussions with, of course, within our co-author community, but also with other collaborators in our research projects. And so interestingly, we are currently working with applications developers that have some interesting use cases that are beyond the traditional data center and say multi-access edge computing scenarios. So we hope to also get some more kind of insights and perhaps also feedback from them. Okay, maybe so the feedback, if we were to summarize that, again, thanks very much, Xavier, for providing that. So we have a to-do item list here. There's some of course editorial things to take care of. It was an interesting point raised. So yeah, to what extent yeah, should we consider packet processing as really a computing in the network thing? I mean, we have some work we also talked about earlier on the topic. So yeah, could be, I mean, interesting to discuss. So how much we want to do on that in the future. I'm not excluding it, but so in general, I mean, the idea of adopting a draft is, of course, also that the group takes over the change control of the draft. So it's also now up to you to really check it more carefully and tell us what needs to be added. So then there are questions of discovery in the research challenges. So whether that should be like a prominent topic there. We haven't made up our minds yet, but of course it's a good question. Xavier also raised an interesting question as to who's actually the user in like coin scenarios. I mean, is it like the traditional, maybe human mobile user or something, or is there also a different notion? So who is in that sense invoking a distributed computing, for example? So there could be that the like user initiated foreground things. We could also have some so kind of background processing or something. So we actually, we are currently discussing with like telco operators, for example, whether there is a point in using like a coin approach to network management, for example, and that could maybe go into this direction. Also related, the lifetime of and life cycle of in-network compute functions. So is that something like more like a service or something like a one-shot status invocation? Of course, there is probably both, but so maybe better describe these different types of computing, perhaps. Other things that we came up with, result provenance. So there are these use cases where computing is about data processing, and so that's interesting. It's a important question. So how can you trust the data, and how can you trust the computation steps on the data? How can you say anything about that? Bit related perhaps to the previous presentation, impact of mobility. So sometimes you want to, maintain a set of distributed computing nodes, for example. How is that possible, or what are the challenges when things are more dynamic? So in general, this is a bit, additional thoughts we put up together. So we had this discussion about computing in the network, whether it's in-network computing or on-network computing. So I think what we probably don't want to do is, integrating computing in the, say, big internet, capital internet, in a sense that, we are changing the internet architecture or something that every router has to be programmable or has to support computing. And also, I don't think it's leading to anywhere when we have to develop alternative cloud architectures or these kind of things. But we think what's interesting here is also maybe approaching this from two perspectives. So applying internet principles to distributed computing. For example, thinking about the function or work split between things like routing, forwarding intelligence, mapping systems, like the ones we heard about before. But then also in the other direction, learning from how distributed computing systems work today, and maybe how this could be, on the one hand, supported better by say a network approach, but also what can we learn in terms of mechanisms, consensus mechanisms, these kind of things for building systems. And so while we're not kind of probably changing the whole internet, we may end up with a set of technologies in the end that help us to do distributed computing better for specific environments. And I mean, they could then leverage coin-derived principles, perhaps. We don't think that this should be necessarily constrained by our understanding of how communication, TCP/IP-based communication works today. But of course, there's also probably one end of the spectrum. And we have seen that there are many domain-specific solutions, industrial IoT use cases, and so on. On the one hand side, it would be good if they are not only point solutions. On the other hand, of course, there is also good reason to have maybe kind of specialized implementations of a coin system in these environments. So we haven't really put this into the draft yet, but so we think that computing in the network is a bit more than just forwarding packets to nodes that happen to host services on VMs or represented as processes. Because this can be done already with various tools. So I think there's potential to go a bit beyond that, and so embrace the idea of supporting distributed computing better, as we discussed before. So not just building pipes between processes. And and so I think we mentioned that last time. It's probably not so we don't see much research potential in enhancing TCP, adding new headers or something to support in-network computing in that direction. So because first of all, probably doesn't really fit so well to the end-to-end stream model when you have to implement hop-by-hop processing or data manipulation. So I think if we run into this problem, we probably should rethink our requirements fundamentally. And so I think it's really important also to keep the security model in mind. So of course we can, manage to steer packets to any point in the network where some compute happens, but we don't think that's necessarily helping so much. So it's also really important to have a good security story. So as we mentioned before, can you trust the nodes? Can you trust the computation, the results, and so on? So that's a bit. I mean, it's not only like to just picked this TCP example as say one way to illustrate what's probably not so interesting to us, at least in our view so far. Okay, so here's the plan. So we will resubmit the draft now with the new name. Currently trying to think about more representative use cases. So I mean, we don't want to just fill pages with describing all kinds of possible use cases, but should be they should bring some merit and interesting aspects. Try to include more different technology variants. We started some discussion or work on say taxonomy type of text. I think we could also now update the draft a little bit with capturing like recent activities in Coin, and so that's also on the list. But the overall goal remains. So I mean, this is not about laying out a Coin architecture or something, or of course also not any kind of solution, but really more as a document that helps us to understand the problem, and so hopefully it's going to be useful for that. Then of course it may not cover all the possible variants of network computing, but so let's find like a 80% coverage here. Okay, that's it for this time. So I'm done.
Thank you. I don't see anybody in the, there's a lot of chat, but okay.
Quick question was your reference to the use cases draft. I
Yeah.
kind of like the idea actually of using that as a holding place for use cases that are interesting, because then every other draft doesn't have to re-enumerate all the use cases. Was that what you were saying, sir? Or were you saying you were wanting to align with it? Can you clarify?
Yeah, I mean, use cases in terms of, you know, classes of use cases. So representative use cases that, yeah, reflect some different categories of coin concepts, or realizing coin concepts. Of course, I don't think we should use an internet draft to collect all kinds of possible use cases. I mean, that could also be done on a wiki page or something. But yeah, some level of abstraction would be good, I think.
Any other question? If not, thank you very much. And
Thank
we
you.
will
Okay,
go to the next presentation.
Hang on.
Oh.
It looks like Ike and Phil both have questions.
Yeah, hi, here's Ike. So one of the authors of the use cases draft. I just wanted to chime in here. So our idea was actually just, as Eve said, to have a collection of the drafts of the different available use cases that we have. And then, similar to what Dirk said, we then want to create also some form of taxonomy out of that, so that we just don't only have that collection of use cases, but also some further good coming from the draft. Because just as Dirk said, we could also collect use cases somewhere else, but we also want to provide then some form of taxonomy from that. But I will talk about that later as well.
Okay.
Yeah. So yeah, I mean, we're happy to find a useful split between topics, use cases for with the other draft. So yeah, I think that let's discuss this offline. What is a good way to organize this?
I think what would be, hi, it's Phil here. I think what would be nice, not just to make a taxonomy of them, but to try and draw out the kind of key requirements for Coin. So, collect them together in a way that it's the requirements that come out rather than just a taxonomy of use cases.
Yeah, so I think we are a bit reluctant on really calling this requirements, because I mean, this is research.
Fair enough.
I mean, so it's a bit more collecting ideas and putting them together in an understandable way. We can't really mandate so many things here.
Yeah, perhaps that's the wrong way of putting it. But what are the sort of weird or surprising things that come out of these use cases that mean that you need
the common elements, maybe.
Yeah. Okay. Good.
I don't know.
Okay,
not
so
sure.
we're out of time right now. Okay, so I think Eve, you're the one who's going to present the next one, right?
I am.
Okay, there you go.
Okay, so I think Dirk. Okay, let's see. Go back to this.
We're running a bit behind, so
why don't I make it really quick? Let me just make note of my time. Okay. What did you want to say, Marie-José?
Nothing. It's fine.
Okay. Then let me put this in full screen mode. Okay. One change that happened was that Xavier joined the drafts. We had kind of two phenomena happen. We started out life as having a draft that was specifically around data discovery for Edge, based on some use cases that, in fact, we presented pretty early on in the beginning of the Coin endeavor at the BOF. And ended up that there were quite a few other discovery drafts that it generated, kind of an overarching discovery problem statement, and also then a mobility discovery.
Eve, we don't see your screen at all.
Oh. Okay. Start again. Okay.
Yeah,
Are you
there we
seeing
are.
it now?
Yeah.
Okay. Okay. And so the point was that we kind of expanded into 3 drafts around discovery, and now we are beginning to kind of recoalesce. And in this latest iteration, Xavier's draft on mobility, the language was included, some of the language was included in the Edge data discovery draft. And it is our intention to revisit whether we need multiple drafts on discovery or just one. But I wanted those of you who hadn't been following to understand at least the lineage. Let's see if I can get this to move. For some reason, I'm not getting controls. Are you seeing anything? I'm not. It seems like my computer
It doesn't move, no.
It's not moving. Okay, let's just do it this way then. Okay. So what is the problem here? The problem, as alluded to by all of the talks today, is that increasingly the compute capabilities are really scattered around the network everywhere. And that really has blurred the line between what's the network and what's compute and what's storage. And just as the compute is getting scattered, increasingly a consequence of that is that the data is getting created everywhere. It's getting cached and copied everywhere. And each time it's computed across, it's transformed and becomes yet new data. So data begets new data. And so we have this problem that data is scattered. And especially, again, the problem sort of originated with these sort of edge use cases that we were examining. But what it leaves us with the predicament is that we really would like to understand then, how do we find this data or pockets of data, data lakes or databases, and within those pockets of data, specific data objects, where are they located? And we'd like to do that to locate this distributed data in some kind of open and standardized way, instead of in sort of proprietary silo fashion, because there are many solutions to this, but how do we kind of liberate the data from all of these disparate places? And when we say data, we mean data that's measurement data. That's sort of the typical IoT definition of data. But also when we talk in terms of what it is that we're sending across the network, really the network is agnostic, and protocols would be agnostic to what it is they're sending. It's really just a bag of bits. And in fact, sometimes we're sending around the compute itself, programs and services that are the executables or functions or algorithms, because we need to move them around, because in fact, the data measurements, they're so enormous. If it's video or something else, sometimes we can't move the measurement data or the monitoring data. We have to move the compute to it. So in that case, it's the bag of bits. And then of course, there's all the metadata that describes either the data or the applications and other things. And those might describe, for example, resources.
Eve, can you make the font slightly bigger?
How's that?
Yes, it's better.
Okay. And so last time there was quite a bit of discussion about, we were kind of on the brink of asking the group whether or not the Edge data discovery draft was ready to be adopted as a draft and in fact drill down, as Dirk alluded, to this issue about discovery. To what extent is that an attendant problem around Coin? But we were really challenged in the debate and question and answer at the last IETF. And so we thought we'd take a moment to say, why do we think that discovery, particularly around data, is fundamental to Coin? And it's because, at least my mental model of what coin is or what computation is that it's a function. It gets performed on data, and it typically generates data. And so all three of those aspects, each, like the input data, we need to marshal it from somewhere. We may not be, things are not always tidy, containerized workloads. We may need to marshal the data from somewhere on the fly, particularly in autonomous kinds of situations. Furthermore, it's not just the data we may be marshaling, but we may be needing to marshal the function itself, the compute, the algorithm, and so forth, because again, sometimes it's contextual what it is that we want the function to be. And then sort of in this last stage, of course, there's output from the computation, and we need enough context and metadata about our place in the universe, whether we're mobile or changing dynamic network situations, to understand where do we place that data for potential reuse, whether it's cached or replicated or archived, for that matter. And so that's really the crux for why we think data discovery is fundamental. So we outlined why do we think that COIN might be the right place for this kind of discussion. Well, research groups are good staging grounds for it says mature ideas, but it says, I wanted to say mature ideas that are not mature. And so in fact, data discovery is an early stage idea, and as such, it has no specific protocols or architectures that we're recommending at this point. But as I stated, data discovery is motivated by compute, but it's also motivated by mobility and network dynamics. Linking back to the previous talks. And then, why wouldn't we put it in COIN? Well, it seems a bit off topic based on our original group charter. It would seem less off topic in terms of if you were following the progress of these discussions since the beginning of COIN. We did have this problem that the documents we've had multiple documents that seem to have sort of blurred the relevance or, grown the scope, and that maybe one of the outcomes of these debates is that maybe we need to better characterize what needs discovery in COIN and really focus in on that. So that was really the recap. And so really the question to the group is, do people think that it is relevant? And if so, is the document at least mature enough, having been now through about 5 iterations, to request adoption?
So I guess you mean the first one, right? Because there's 3 of those.
Oh, no, the one that's the most mature is the edge data discovery.
Okay, so the first one. And for the sake of time, I think we could put that question to the group. I think you were right in saying, yeah, people were thinking it was a bit off topic, but again, when I started listening to, like I said, other meetings, and when I started thinking about it, and I did meet with Xavier here in Montreal, I think we had a good discussion about what it could mean. So we could push that to the list. But I would ask you the question you always ask of everybody who presents into this group, Eve. Is it only you guys, or there's actually other research on that?
Well, I don't know. I mean, like, I could bounce this question back to Dirk. I mean, it was on his list, and we did not coordinate. I didn't prime him to say that he thinks that discovery is a research topic or a research direction for COIN. So perhaps hearing from people from these other quarters would be a helpful, different perspective. I mean, my position is like, you can't do compute without data, and you need to find it. And whether we think that these different flavors of computation that we refer to in the title COIN represent the kinds of computations that are less tidy than containerized workloads, which was, I think, what the debate was about last time, and that they're going to be these more autonomous situations with more dynamic contexts like mobility and network changes and programmable networks, where we're going to need to find the data more on the fly, and we'll need to be assisted through discovery.
Manisha said we have last in the queue. Maybe
Yes.
Lars,
Can type.
wonderful. Come debate with us.
Hey guys, yeah, so this is actually a more general point, not so much related to this particular document, although we can have a discussion here too. So I want to say that I think actually we're wasting a lot of time discussing whether something should be adopted by a working group. And it's actually not a working group, it's a research group, right? Or not.
Oh.
I think that is just a waste of time, right? I don't really care whether something is a research group document or not. It doesn't matter. But I think a much more worthwhile question is to ask is, would this group want to discuss more of this in the future, like this particular research or not, right? And then whether something is a research group document or not, who actually cares, right? It doesn't matter. The point is that you want to have a discussion on something, and therefore also I wouldn't be so limited to the charter, right? Whether, you know, if there's no community here that discuss this further, it doesn't matter even if it was in the charter, right? And on the flip side, if it's not directly in the charter but people want to discuss it, what's the harm in it to do that for a while? Right? So I would not act so much as a working group, you guys. I think it's actually harmful to what you're trying to do. Thanks.
Okay, thank you for that advice.
So I would say we've had comments on the opposite too, so I think we're going to bring that in the middle, or they could take. But I agree, Lars, that and this is actually something that we discussed about this meeting, that we were completely dominated by drafts. But and I see Mike saying, is it harmful to ask for urgent adoption? No, but yeah, maybe it's not that necessary. But I would say that we were Lars, we were very much discussing the fact that we were dominated by drafts, and that we wanted to have more time for like more research presentations, and this is what we want to do for the interim, because again, that's the way it happened.
Yeah, and also I think you want to have much more Q&A than you're having, which is not a whole lot. And Mike, it's not harmful to ask for research group adoption, but I think it just wastes time, and it doesn't matter. Why does it matter whether this is a research group document or not? It, you know, I really at this point at least I don't really see the value in debating this in the meeting, where we could actually talk about the technical content rather than whether we're handling it this way or the other way.
Yeah.
Point taken. Thank you.
Thank you.
Dirk, did you have a comment? Dirk,
yes. Hi, good morning. I mean, I haven't had an awful lot of time to look at the drafts yet, but I do think the topic is extremely important. But I wonder, in terms of RG relevance, it's not about RG adoption, it's about RG relevance. To try to ask the question on data discovery more, I mean, Coin has two aspects in the title. One is computation, and data discovery is computation. Right? I fully agree. But I think what would be interesting to ask questions as to what extent is it an in-networking question or relevance? What is it network really can do to aid the problem? The problem of distributed data is a huge problem, and it's extremely relevant in some of the discussions I had recently, for instance, with transportation, automotive, where the trend stays at data centralization and compute centralization purely because OEMs and car manufacturers are very concerned about data floating about and not being under their control. So it's a huge problem. It's very relevant. But I think the question for Coin would be to not forget the in-networking part. How is it that in-network capability can aid the problem, and not discuss problem about data discovery in general? Because that's a computational issue, which hugely interesting, but I'm not entirely sure how much Coin can shed light on, because there's a huge community out there. So it would be good to hone into the in-networking part quite a bit. And I can half raise my hand on that because I have a little bit of interest in that. I have to see how my time allows to more specifically contribute to the draft, but at least I have an interest in it. So see it as a half hand for contribution.
Okay. Well, but you're next, Dirk. So, or you and Ike. So that's.
Yeah, I'll do the presentation.
It's you guys.
Yeah. So can you grant me the presentation rights?
Yes, here you go.
see. All right. So now that we've had a discussion already on the use cases, like before here, let's get it going again. So as Jeffrey has already said in the beginning, we're now moving away from the only sole focus on industrial use cases, but we're now also open for other use cases. In this quick presentation, I wanted to give you our intentions, what we want to achieve with this draft, and as you have also heard now, Dirk has joined us in the group of authors. So the premise of the draft previously was that we wanted to highlight the importance of Coin for industrial use cases. So we collected quite a bunch of them in that draft. But then Dirk suggested that it might be a good idea to have a draft that is rather open for other use cases as well, because then we can actually cover a larger spectrum of requirements as well. And this is why we have now opened up our draft, so that we now want to really, also take a look at other use cases. This also reflects in the new structure that we have in the draft. So as you can see, we have moved down the industrial use cases part from the title down into a section level. As you can see on the bottom, we have quite a bunch of other use cases that we are planning to insert into the draft. Currently, they are only placeholders, we didn't really find the time to insert them already. So that's one of our next steps that we want to do. We then want to have a similar structure for all of those use cases. So as you can see up there in 3.2.1 and 3.2.2, for example, there's also some part of that in what Phil suggested a couple of minutes ago. And then finally, we want to work on those findings that we have there, and then create some kind of taxonomy, find common building blocks, and so on. In the following, I want to go a little bit into more detail on the different aspects that I've shown here on the slide. So first up, the new use cases that we have already. So as you can see, most of them will be coming over from the App Center's draft of Dirk. So we similar to what I said in the presentation of the other Dirk a couple of minutes ago, we think that it might be a good idea if we have like this use cases collected in a central position where we can then really point to from other drafts then, so that the other drafts can then really focus on the context, on their real content, and like then everyone else does only have to know the central use cases draft or the use cases that are in there, and then understanding other use cases or the other drafts is then perhaps a bit easier. But then, as you can see here, in the 5.2 are also thinking about some form of Edge, AR, and VR. So Dirk has a use case or some ideas on that. We also thought that it might be a good idea to potentially move some of the content of the now expired draft of Marie-José over to this draft here. And there are also a couple of other sources that we could think of at this point, so to fill this initial set of new use cases. But in general, we're also open for other use cases. And what we generally intend to have as a structure here is like some form of threefold approach. We first want to have a short motivation that generally describes the setting that we're looking at. So using the example here of this in-network control, we just described here that cyber physical systems are increasingly complex, and that local control in that scenario is not often not really sufficient anymore, and that a central control might help in those cases. So just setting the general stage for the use case then. After that, we then plan on having characterization and requirements. So Phil mentioned that we also should collect requirements, and that is actually what we want to at least enable with our approach here. Using the example of the in-network control again, we would characterize that as a simple control loop that is running, and this control loop might be influenced by various factors, and it generally requires low and stable latencies. So just to have that as an example here. And then finally, we also want to include a section on potential approaches where we think that it might be a good idea to highlight how stuff is currently implemented, maybe, or how we would envision it to be implemented using Coin. And then also perhaps formulate some kind of research questions, so to actually state what is really the central idea of this use case, and what is the real value for this use case. And in the case of the in-network control, we would here, or we've put here that we want to have an approximated imprecise control in the network for a faster response, and then having slower responses coming from afar, so from a central position maybe. And one of the biggest questions here, or all the research questions mainly, revolve around the question how the different approximations that we might use here can actually be derived. Then our main goal, as I said, is not only to collect the different use cases, but then also make something out of them. Here I already said that we want to create some form of taxonomy. And for that, we want to then actually use the structure that we have for the different use cases, so the common setting with the requirements, perhaps also analyze algorithmic properties of solutions that could be applied there, and then try to find common requirements, common combinations of requirements, common building blocks, and then really try to define different classes of use cases that we have. So I think Dirk Kutscher also said something similar to that in his presentation. So this is really what we intend this draft to be. So a collection of classes of use cases with certain requirements, a list of requirements maybe, so that then work can really be derived from those use cases, and then really focus on certain aspects of the use cases or solve problems in them. And the big thing at this point here is that we need more use cases for that. So currently, as I said, we only really have the industrial use cases in there. The other use cases from the Epicenter draft will move over eventually. But even then, we only would have like 3 large groups of use cases. And so it would be really great if other people here would also have the interest of contributing use cases. So in the first presentation, we had like this AI to the edge use cases with the auto and the cyber cases. So that sounded really interesting. And that's really open and looking for collaborators at this point, so that we can then increase the diversity of the use cases, and then really find interesting requirements, and then hopefully get a good basis for future work at this point. So this is then now the last slide. We were not really sure about our status as a research group draft, but in the beginning we solved that, so let's skip over it so that Lars is happy also. What do we need for our draft now? We really need input on our approach on how we want to describe and include use cases. So if this separation in characterization and requirements and approaches make sense, if you guys have better ideas for that, please tell them, so that we can then really improve the approach here, and perhaps maybe make it more easy for other people to contribute as well. We also need new contributors with new use cases. So we'll add the draft sources to the research group GitHub soon. So then text contributions should be really easy. And And yeah, then the plans for the immediate future are that we will first move the use cases over from the App Centers draft, and then and follow our own guidelines regarding the descriptions of the use cases there. And then as soon as we have enough use cases we will also want to start with a rough analysis of the use cases so that we can then start in the direction of a taxonomy. And yeah, with that, I would already be at the end. And hopefully now a lot of people show up in the queue saying that they want to contribute to the draft. So thanks.
Thank you.
So I see.
I know I'm in the queue, but who else is there?
I see Dirk in the queue. Dirk Trost.
Yeah, thanks, Ike. Just to continue on what Ike has presented, but also connecting to what Dirk had said before. The taxonomy part is going to be a really important one. I would really like to invite also contributors specifically to that as well. It's not only just the new use case, but also taxonomy. Because I think one of the critical pieces in the use cases is first we get a place where they are gathered. That was the first idea of merging things, and I will say that later in our own draft, but we're going to do that. So just to move them out of individual drafts, that's a good thing. But it also allows us to essentially look at the use case and make sense out of them. I think Dirk's comment about there's a lot of edge and cloud here is a very important one. It also ties back what I mentioned before in the data discovery. I think key to the use cases will be to a little bit sort them out, or at least find a taxonomy that kind of allows us to point out what are the Coin specific one. And Coin, again, not just computation, which sometimes leads us to edge use cases, but the in-network part. And that's kind of like what I'm looking for in the taxonomy, to find out what are aspects that we can use in the taxonomy to look at those use cases from that perspective, to really sort out the ones that are still interesting and cool. I mean, there's nothing wrong with the use cases, but the ones that are more relevant to the networking part and are not just, in air quotes, just edge cases or cloud cases, which might have an interest of their own, but maybe doesn't add much to the networking part. So that's the taxonomy bit. That's, I think, really, really important. And I'd really like to see anybody's good ideas to that as well. Another thing, I just looked through the participant list because I wasn't entirely sure if he would join given the early time. But I will connect that to Ike directly. I had spoken to a potential contributor from UCL on use cases. So probably, given that I can't see him at the moment in the participant list, I probably will just make the connection. So we may have already a contributor there. Just wanted to make people aware of that.
Who is that?
David Griffin and Miguel. I'm not sure if Miguel is here. I didn't scroll that far down. No, he's not. Okay. Right. And Miguel Rio from UCL. We've been talking to them about use cases related to arts and theater and how some of them being extremely demanding on the network and how the network might help. But again, the question there would be, how can in-networking functionality really help, or is it all down to intelligent, maybe edge software, which is still an interesting use case, but maybe not that relevant for this group. Thanks.
I was the other person in the queue, and it was just to tell you guys that if you need my help to move the material from my expired draft into yours, I'd be more than happy. I was supposed to get help from other people to update it, but if it's just like update, making it was a use case anyway, so I'd be more than happy to use it as a use case in yours.
Sounds great. Thanks. So I don't see any other people in the queue. No. So thanks again.
Thank you very much. The next one is a new contributor from Japan. So I will let Hiroshika, start this presentation.
Can you hear me?
Yes, we hear you very well.
Okay, thank you. But I don't see your slide. Can you display your slide? The slide I sent you.
Oh, Eve, you're the one who does the slide thing.
I'm getting sleepy, and now I'm forgetting how to do this. No, I'll figure it out. Hold on.
Come on, you're 3 hours behind me. Don't start.
I know. This one was
Transport.
Is it the transport?
Yeah, transport.
Okay, and let's do this. Okay. Oops, sorry.
Okay. Yeah, no problem.
There you go.
Yes, that. Yeah, thank you. Hello everybody. I'm Hiroshi Kasai. I'm from Preferred Networks and the White Project. I'm going to talk about separation of data paths and data flow sublayers in the transport layer. This draft is proposed for transport layer and TSB working group, but some of the topics are related to the in-network computing and Coinrg, so I want to talk about that here. So thank you for taking your time. And we start thinking about the layering architecture for the new distributed computing paradigms, including the mobile or multi-access edge computing and in-network computing. I personally think the requirement for the transport layer protocol is different by computation models, such as the data center networking or geographically distributed environment. So I'd like to begin with a more general layering architecture rather than the specific protocols to extract a common functionality for the future protocol development. And yeah, as you know, the internet has been based on the end-to-end principle. So the complicated or the complex functionality is implemented at the end host, and the network intermediate network is done. So according to the end-to-end principle. But recently, the network becomes more smarter. So QoS is introduced, middle boxes are everywhere, and recently, new distributed computing paradigms such as the edge computing, in-network computing are introduced. So middle boxes introduce a non-transparent functionality that may be added by that requires to load packets to middle boxes or packet-based policy-based routing or software-defined networking technologies. Distributed computing paradigms requires to make the network smart. And these often use overlay networks to route the packets to the target computing resources. Next, please. Yeah, thank you. So I started thinking about the transport layer functionality to separate the functionality into the multiple layer for the future protocol development. So in this draft, I divide the transport layer into two sub-layers. One is the data path layer, and the other is the data flow layer. Data path layer is related to the data path, as it's a name, and the data flow manages the data flow or more complicated protocol handling for the data flow. So data path layer, the functionality for the data path layer is the following. For example, the trajectory or waypoint handling to designate the waypoint for the some kind of flows, and the bidirectional connection, and resource management for the networking, such as congestion control, and the data flow multiplexing over the one path, and the packet duplication may be implemented for packet loss recovery for lossy network or links like FEC. And over the data path, data flow layer adds some functionality about the retransmission, flow control, flow prioritization, end-to-end security, or multipath protocol functionality. So data flow protocol requires more memory to handle the retransmission or buffer receive buffer management. So I want to show some use. In this draft, I wrote some use cases of this draft, but in this presentation, I'm gonna dig into the in-network computing. So in-network computing, I think I don't need to say something about that because everyone are specialists. But in-network computing has been researched maybe more than 30 years. The active network is one of the beginning early research of the in-network computing. And then the recently is the service function chaining has been discussed in the IETF. And in the data center networking, data aggregation redistributions is used for all reduced procedure for the distributed deep learning. So in-network computing has been focused recently again. Oh, sorry. Next, please. Next, please. I have talked about this slide. Yeah, sorry. And next, please. So, but the computation model for the in-network computing varies by the applications. So this is the simplest in-network computing model. So nothing no intermediate routers stores any state of the computation and data path information. So programs are installed, deployed in some in-network computing components or in-network computing router like this. And the packet going through the router is processed according to the program. But these routers don't store any state of the packet or data path. So in such case, we can leverage ECMP, low-cost multipath, because the data path is not required to be cared for the in-network computing. So this is the simplest computing model for the in-network computing, but usually this isn't. The more complex the computation model is used. So next, please. So usually the packets, the data path is more important for the in-network computing because the different programs may be deployed at the routers. So for each flow, and each flow needs to be aware of the data path and the waypoints to apply the program to the packet. So in such cases, for example, the service function chaining uses policy-based routing or segment routing or SFC protocols to classify the packet which where to be routed. So in this model, a waypoint must be designated and controlled. So routers request to manage the state for the data path. But each router, each in-network computing router do not store any state of the packets. So it just applies the program to each packet without any state. Next, please. So this is the figure below is the example of the layering for this computation model. So the data path needs to be aware in this computation model, but the data flow, the in-network computing routers do not store any state, so that they don't require any flow control or retransmission between the routers at the end host. Next, please. But usually, the in-network computing is more complex. So they requires to aggregate the data multiple packets or compute using multiple packets in a flow. So the in-network computing routers or node requires to terminate multiple flows to perform data aggregation and processing. So next, please. So in this model, the in-network computing routers need to terminate the data flow. So they introduce the data flow layer. They need to implement the data flow layer protocol at the in-network computing node. Next, please. So I will have 1 minute. So this is the summary. So I propose the separation of data path and data flow layers. So data path is to be aware of network resources and the trajectory or waypoints. the data flow layer is to be aware of computing resources and the flow level integrity. So next step is to improve the IDE by adding analysis of existing protocols and adding more use cases and example. And I think we need to propose some protocols for data path layer and the data flow layers. So thank you for listening. That's all.
Thank you very much. Is there anybody in the... Yes, there's two people in the queue. Curity. And well, first Dirk.
Sure, I go.
And then Curity. And then Jord.
Okay.
I don't know who's going first. Go ahead, Jörg.
Okay, thanks. Yeah, thanks, Asai-san. Interesting. So, I mean, most often compute functions, want to do something on the payload, so the application data. So, what security model should we apply for, your data flow layers? I mean, would you terminate a security context in the network, or how would that look like?
So I think the security function is to be implemented on the data flow layer because it buffers the data and the payload. I mean the protocol level payload, protocol data unit. So I think the security or encryption should be applied in the data flow layer, not the data path.
Okay, thanks.
Hey, I have a question. If you go back one slide, I think it's one slide.
Oops, here, let me put it back in this mode. Hang on. This slide?
It's the slide, yes, this one. So if you look at the data flow layer, where you got the data flow connecting to another data flow layer, connecting to the end data flow layer, the application layer is expecting something. Typically, they just expect that the packets go from here to here, and then they'll deal with it. If the data flow layer introduces some compute, if you think of the left as an end user and the right as the cloud, your usual content network or whatever, and in the middle, someone is doing something. What's the end-to-end expectation anymore? That the application sends something from the left, and the right wants to take it and do some compute on it, but in the middle, somebody's already done some other compute on it. And it's not only security, but what is the end-to-end correctness of what is going on?
Yeah, good point. Yeah, I think we need to think about that point in more detail in future. But I think the application layer needs to take care the service level functionality or service level something. I mean, usually the application specify the service identifier instead of the this kind of the middle boxes or the waypoints of the computation. So application layer should handle such kind of the service level integrity or service level functionality, I think. But I think we need to discuss more about that.
But then it should be aware of the midpoints and what's going on, or at least that there exist midpoints, because otherwise how do you guarantee end-to-end correctness?
Oh, yeah, right. I think this draft focuses on the data plane function. So I think control plane requires to manage the how to load or where should be the waypoint for this functionality or for this service. So the application layer should control such kind of things, and the data path layer and the data flow layer is used for the data plane protocol, I think. in my opinion.
Okay. I think it's worth thinking more, but yeah, thanks. Thank you.
Yeah. Thank you very much.
Maybe we can take one last fast question and send the rest of the queue to a discussion on the mailing list, or actually I see nobody on Slack, but that's okay. I usually say to continue discussion on Slack. So Dirk or Uma.
Uma. So it's a one quick question. I think thanks for the good presentation. So I have my question is, you pointed the active networks in the beginning of the presentation. And the first question Dirk also asked, it's mostly massaging the payload, right, with the data flow layer with the small program there. So is that the use case you have in mind, or so are you doing anything which is not to do with the payload, right, but still applying some service, the compute service on the packet here?
So actually, I don't have any specific use cases for the application layer, but we want one of the application is of this how can I say of this the draft is that is for the data collection. So we collect many data from the sensors from in the IoT. So in such cases, we need to collect the many data, but some of the data should be aggregated to reduce the storage cost. So that is one of the use cases we are thinking about.
So in that case, you are not talking about any application payload, right? So you are just collecting and aggregating. The compute function is basically aggregation of the data.
Yep.
Okay, thanks.
Okay, thank you. So it's 1:36. I know here. I know that they're going to cut us after 5 minutes past. So we still have 4 presentations. Dirk Trossen, you're the next one. Do you think you could? Yes.
Say again?
You think you? Dirk Trossen, you're the next one, and you have 2. I was thinking, could you make them shorter a little bit instead of 20 minutes, making them shorter so that they squeeze in less time?
Yeah, I will try. I will try certainly. Yeah, they are
so that at least Ina gets some time, and that we get at least 5 minutes for Philip at the end.
Yeah, I will do my best. Eve, I don't know, are you able to share the slides, or did I send them too late? Otherwise, I'll try to share them from here.
I think you sent them too late. I don't have them queued up here.
Can you give me the? If you give me the queue, I enter the screen queue.
Yes, we will do that. You are granted.
Okay, thanks. This was useful because I can do both of them from the same share here. So yes, the transfer. I hope you can see that. I hope I'm still sharing the right screen.
Yes, you are.
Good. Good. So I only copied the abstract here, but the important sentence is the very last one. So there are various questions that at the moment are being asked about transport protocols in connection with Coin. And again, the last sub-sentence is very important to the point I also made before. We outline a number of research challenges and use cases for that in the draft. And from the structure, these are the main updates. So again, this is only an update on an ongoing draft, hence we're focusing on the updates. Discuss later a couple of the updates we made in addressing and flow granularity. We added a new section 5 on collective communication and for multi-party communication and the challenges that transport has in that area. And we also renamed section 8, which was the previous, obviously a different numbering before, into transport features, where we discuss reliability and flow and updated these subsections. So on section 3, what we've largely done initially, at least, given that I kindly invited me to join as a co-author, is to make linkages to other work, and that's not meant to be limiting. It's limiting at the moment, but we're not limiting obviously the draft to that, because we invite later to make other links as well. So here are specifically links to the service routing discussion in the adjacent draft, which I will present later separately, the App Center draft. We also amended the research questions by various aspects on node selection, constraint-based decision of that selection, and also representing the treatment by coin nodes. There are several research questions. If you recall the structure of the draft, which always asks a number of research questions in each of these subsections. So we amended these aspects in section 3. On flow granularity, we added text on the notion of short-term messages versus the long-term resource management between endpoints. So to possibly separate the message and transaction handling from the resource management aspect for a number of reasons that are discussed in the draft. In particular, to apply error control on the messages and the congestion control on the endpoint relation itself over a longer period. And that has an impact. The reason we've done this, which we discussed in the draft, is it has an impact on what could be executed where by coin nodes. That's the reason why we've done that in the draft. This actually is new, mentioned before, and has been done with a linkage again to the App Center draft, which comes next. And it talks about possibly ephemeral and short-lived multi-point communication that is being done. There are, I think, at least 2 use cases in the App Center draft that talk about this. So multi-point communication that may occur even at the request level only. And that questions the viability of current transport solutions, which we discuss in this new section, and the possibility for coin nodes to support aspects that you would need to do from a transport perspective. For instance, group division into subgroups is one of the aspects we identify that coin nodes could be helped with. Updates on section 8, again, different numbering before. We renamed this section to transport features. They cover reliability and congestion control subsections. We have several amendments in the 2 subsections of reliability. We mentioned, for instance, the possible opportunity to use coin nodes in relation to network coding for reliability. That's one aspect there. We also added, again, a question on what's the unit of reliability. So we linked this to the previous discussion in the flow granularity section as to what's the unit of reliability that one should look at. So we try to connect these 2 texts. And also added a question on the possible use of multi-source, which was missing before, and how would you handle that with respect to reliability. In flow and congestion control, we added a discussion that we again linked to back to the flow granularity section on separating error and flow control, and also the impact of collective communication, in particular when you have potentially forward unicast request and a single multicast response. How do you separate, or how do you join the flow controls into a potential ephemeral resource management regime that you can use for the multicast response? There's some text in there as well. And again, always trying to link this somehow to how Coin can help, so in particular the in-networking part. So I know I keep repeating that, but it's important. What are the future plans? Again, some of this work has happened fairly recent to the IETF, so we are intending to update this, quite quickly. It's a clearer linkage to the various use cases in the revised use case draft. That's again where also, let's say, draft-wise and linkage-wise, things become a bit easier because you can just link to a single draft increasingly, hopefully, and also hopefully rely to an emerging taxonomy that we can link to from the transport draft. So there are these kind of things, more sense-making and linkages in a way that we intend to increase. Also linkage to other coin drafts. We did extend the references already, and they will, there's a lot of work on collective communication, for instance, that there has been a little bit added, but there can be a lot more added. And we also want to obviously add other drafts and the relevant work that's being discussed there on competing frameworks, programmable forwarding nodes, the microservice draft I mentioned already, so that we again create the linkages for the overall sense making. As I also mentioned before, for the use cases, I think similar applies here for the transport, to turn the research questions into something like a requirements language. so that we can shape that out, and maybe at some point even discuss where to collect all those requirements. That's a little bit further down, more for the research group overall. Obviously, we would like to have more input, and I think that's more important, or mostly important, to get more people involved in the discussion, and hence the call for more contributors. And we also asked the question here, but we can skip that given the discussion we had to adopt that as a research draft. At this stage, we want to have more contributors to start with. That was it, and I hope that made it, at least I shaved off a few minutes.
Thank you so much. And I will cut the I don't know if there's, I don't think there's anybody in the queue. No.
No.
So so we can move to the next
the next presentation. Yes.
Yeah. So can you go even faster on this one?
Oh, okay, good. My English language skills. Same structure here. You can read it later. General structure. We still include the use cases, but they will be moved off. We have a very fine small refinements in there for the update, and they will all be carried over the use case draft. That's an easy one. We do have requirements. Again, we leave them here. They derive from the use case, and then we'll see where they make sense in any of the other drafts. Either we carry them over in the use case draft, or if any requirements draft emerges, I think we can take them. They are quite a few, which is good. What we do for now is we will update them in the next revision with a clear linkage to our own section 5. But then when the requirements move elsewhere, we have to restore those linkages. So the main focus has actually been on number 5, on the enabling technologies. And we added more text in a number of subsections. We added new text in section 5, in the ones that are shown red, either new text or added text there. So on the compute interconnection layer 2, we there added references to use L2 switching for interconnecting distributed compute resources, and link to efforts that are going on at the moment in 3GPP and generally in the area of edge computing in 5G. There's some references added and some text. I'll discuss those. And also to point to the service routing in distributed L2 environments as a similar problem to intra-data center service scheduling, even though here you have a distributed layer 2 environment. So there's some text to that regard. That's a new text that wasn't the previous version. 5.5 added text on constraint-based forwarding decisions. So that evolved from the service. Previously, that section was called service pinning, and it was only a placeholder. We've now extended the draft, extended the text in an actual text, and it extends the discussion in the subsection before, section 5.4 on service routing, to include constraints into the forwarding decision. And the constraints between one or more, to have the forwarding decision between one or more service instance candidates. Their point is particularly that load and latency may not be the only constraints. There are a few of them discussed. And again, the relation to the networking part is in the support of the network in the matching operations, because they may need to be coordinated across several routers to achieve the equivalent to a service scheduling capability that you know from intra-data center scheduling of service requests in a distributed setting. So there's some discussion around there. That's where, again, Coin specific comes more in. Also reference to ongoing work, C event Dinecast in the IETF, ICNRG work, etc., etc. So and that's not, is only a start of it. There will be more references if possible. As I said, collective communication is new. As a pattern that exhibited in a number of microservice scenarios, as we have in the use cases, to go not just one-to-one, but true multi-point use cases. We also observed that the patterns may be short-lived. In one of the use cases, you can see that through pulling various frames, and they can be as short-lived as single requests. So here we discuss the spontaneous formation of multi-point relations, and we make references here to ongoing work that could facilitate those, like in the beer working group. There's actually an ongoing draft that addresses that for beer based forwarding solutions. Future plans here, as I've done before, move the use cases, good. Link the requirements for now more clearly to section 5, but then keep in mind to potentially move them elsewhere if there's requirements work emerging in the group. We are quite willing to and happy to do that. There are some other bits and pieces missing in section 5. So section 5 is the core section for the future plans to elaborate on, to make clearer linkages to other drafts, to references. So that goes more into really the overview work and trying to tie in what's been done elsewhere. Ask the same question here, but that's not that relevant on the RG draft. Good. I shaved, hopefully, again, something off. But I may have lost anybody in the queue, though.
Thank you. And again, we're going to send all questions to the mailing list, as some people need a coffee, a tea, or sleeping. Inna, you're next.
Yes.
And yes, you can take maybe 6-7 minutes and maybe a little bit less time than you wanted. And Philip will go a little bit over time to allow you to at least have some minutes to talk about Piccolo.
Okay.
And we'll cut our presentation at the end.
First at the in the interim meeting on your presentation.
Yeah, I know. Okay, I don't know how I can change this. Yeah, so maybe you can share my slides.
Sure. Can you unshare, and then I will.
Yes. Okay.
Then I will take the screen. Okay. Is that your presentation?
Yes. Yeah, thank you.
Great. You're very welcome.
Okay, yeah, so this is on the updated draft on enhancing security and privacy within network computing. And yeah, next slide. So first, a short recap of the draft. So the underlying problem we want to tackle here is that of resource constraints and legacy devices, which are increasingly connected to the internet and also in industrial scenarios. And therefore, there are many sensitive processes and sensitive data involved, but we often have a lack of security and privacy mechanisms. And here we see the potential of in-network computing to efficiently retrofit adequate solutions to this. And in the first version of the draft, we already proposed several specific use cases. So we can imagine to retrofit basic protection mechanisms in the network, such as encryption, integrity checks, authorization, authentication, but also privacy mechanisms, such that networking devices basically act as security gateways and establish secure connections between inherently insecure devices. However, here we have a problem that current networking hardware is missing actual crypto chips. So right at this moment, our possibilities are a bit limited here, but we think there is still room for a lot of interesting research. And we also hope that, yeah, adequate hardware will be available in the future. Yeah, the next, and this is one subject we are already actively working on, is the efficient enforcement of network policies. So here the goal is to provide a very fine granular traffic filtering at line rate. And this is very promising as we see clear performance improvements in comparison to existing solutions with similar filtering capabilities. In a similar sense, we also see the potential to conduct very efficient anomaly detection within the network and exploit this to enable immediate reaction to events, for example, by implementing deadman switches, which are automatically triggered by networking devices after seeing a conspicuous packet. And last, and this is another ongoing research project of us, we also see a high potential to offer a cost-effective and efficient solution for network monitoring. for example, by creating comprehensive flow records at networking devices without additional hardware or software. Yeah, so that's what was already part of the first draft version, and in the updated draft, we now added another idea, which I want to present a bit more detailed. So next slide, please. Yeah, so we call this in-network vulnerability patches, and this works a bit similar to anomaly detection and policy enforcement, but is more specific. And yeah, a common problem of legacy and resource-constrained devices is that they are often hard or even impossible to update, and therefore later emerging vulnerabilities cannot be fixed on the devices themselves. And furthermore, even if updates are possible, these are often just not conducted out of ignorance or laziness. And it's also very time-consuming for hundreds of devices. And here we see again the potential of in-network computing to provide an efficient solution. So the idea here is to basically implement a signature-based intrusion prevention system on networking devices, meaning that we can define very fine granular traffic patterns of known attacks and then just drop matching traffic. One advantage here is that such in-network patches could be easily or even automatically distributed to capable networking devices, for example, in the form of software updates. And thus, this approach offers a high scalability. But the main advantage is that the application would be at line rate. And this is an important advantage for low latency scenarios. But of course, we need to conduct research to evaluate how much we can actually benefit from this approach in comparison to traditional IPS systems. Yeah, so that's it for this idea. So next slide. Yeah, to wrap this up already, this draft is essentially about the research potential we see in network computing for improving and retrofitting security and privacy. And we mainly want to raise awareness for what is possible with network computing in this field. And as I mentioned before, we are already actively conducting research on some of the presented topics, with first promising results. However, I'm really curious to hear about your opinions on this topic, and especially if it's of any interest for this group and what perspectives you see for this draft. So that's it. And yeah, thank you.
Thank you so much. Yes, I think the topic is of interest. It's actually in our charter to look at security. I would suggest that you continue discussing this on the list, which I think is the right place. And I actually put it on the notes, but thank you very much for highlighting the research projects or the research ideas related to this. I think every presentation should have this. So thank you very much. So Philip, you can take maybe 5-6 minutes. We're going to be a few minutes overboard, but I think it's fine.
Hello, have I come through or not? Or do I have to join the queue? Do I have to join the queue, do I?
Yes, no, you just have to.
Can you share my slides, please?
I'm not sure I have your slides.
I think I had them, but...
Oh, no, actually, I do have them. Okay, let me go back. Sorry.
That's great. Okay, they're coming through, so I'll start. So, I'm Philip Erdley, and thank you very much. I'm just going to tell you very briefly about a collaborative project called Piccolo that we've just started about in-network compute for 5G services. Next slide would be nice. So we've only been going a month. So these are just some first initial ideas about what we're going to do and about the use cases that we're looking at. We've got listed some of the people involved there. So some of them are well known to this group. So I think we're very, I'm very pleased with the set of partners and the people we've got involved, and we've got some nice use cases coming, and we're certainly intending to contribute in Coin, and we're keen to to collaborate through fora such as Coin. I think we can go on the next slide. Thank you. So yes, I say it's about in-network compute for 5G services. So a slide very quickly to tell you a bit about the in-network compute side of it. And since we're short time, I'll just talk a little bit about our initial thoughts about the initial directions that we're going to take on the project. So we're interested in looking at joint optimization across networking, compute, and storage. So making the assumption that all the nodes in the network have compute and storage capability in addition to networking, and how you can jointly optimize across them. So kind of multi-objective optimization, but making sure that's done in a way that's tractable and scalable. We're interested in looking at the distributed computing aspects. So, looking at kind of pi calculus, so how you distribute functions across in chains and meshes rather than the current lambda way of doing it. We're interested in looking at resilience and scaling. So, today the approach is to make the infrastructure reliable and add quality of service into the infrastructure, which is kind of what things like MEC do. So we're interested in looking at scalability and reliability through instantiating functions and reinstantiating functions rather than making the underlying system highly redundant and scalable. So, we had a bit of discussion in the chat and one of those previous talks. So there's, that's about state not being held inside functions beyond some short life, but put in storage. And I think that kind of overall our grand vision is that the network it's the network will provide transparent in-network computing in the similar way to how it provides transparent packet transport today, and that being a fresh dimension for permissionless innovation and growth. So that's kind of the overall approach that at least we're starting to take now. If we go on the next slide, so I've got we've got some use cases, services that we're looking at. So at the moment, there's 4 in particular that partners are interested in looking at. I've got a slide coming up on the vision processing and on the automotive side. We've also got partners interested in the smart streetlights as a scenario, and we, meaning their BT, who I work for, we're interested in this not only as a platform, this kind of in-network compute, but also using the technology to do autonomic and scalable network management. But anyway, I've got, so if we go on the next slide, which is about the vision processing use case we're looking at. So we've got a UK SME called Sensing Feelings. So they have a product at the moment, which is camera, which has in the camera or next to the camera a chip that does visual processing. So they have their customers, or what they do is provide to their customers insight into people in real world spaces. So that would be things like in a train station, how do people flow around the train station, or in a shop, where do people spend most time, which department, or at a conference, are people interested in what the speaker's saying? Are they excited, or are they just doing their email, or have they fallen asleep? So what we're looking at in terms of Piccolo is in the camera having just a simple image conveyor and doing the visual processing in the operator fog in the edge, that enabling them to get into kind of long tail, because the sensor would be much cheaper device, or maybe to, if you've got lots of cameras in the train station, one human trying to look at 100 cameras, instead doing automated attention focusing, which picture is the most interesting thing happening. So that's vision processing use case, and the first kind of example we're looking at. We go on the next slide. So we've got Bosch in particular, who have interested in in automotive use cases. That's 60% of their revenue comes from automotive stuff. So the first use case we're particularly interested in there is infrastructure assisted driving. So this is electronic horizon, or kind of seeing around the corners. So at the moment, the product is used for driver assistance. So this would be things like suggesting you slow down a bit and hit the green lights. And at the moment, the approach is you've got these roadside sensors that send their information to a central cloud, and that then pushes the information to the cars. So the approach we're looking at is to have edge clouds. So the information goes into an edge clouds, which would do kind of localized collation analysis and distribution of the information. That would enable kind of things to be done more efficiently and to be done faster, and therefore, as it's done faster, it could be more suitable for automated driving, and enable you to drive faster even in more dangerous, or the car to go faster even in more dangerous conditions such as a fog. So I think, given the time, that's all I'll say, and just say that alert you that we've got this coin-related research activity, and we've got some use cases we think are interesting, and some early thoughts on our approaches, and we're highly motivated to contribute here. That's it. That's all that I think, given the time, that'll do.
Yeah, so we're going to be very interesting to see. I think the whole group. What do I say? I say we are going. I sound so regal suddenly. Maybe it's the British thing. It's the Queen here is very popular. Not the Queen of England. The show. Actually, the Queen of England is not popular here, but
it's late.
Yeah, we're Quebec here. I guess the only people who understand us live in Scotland. But yes, we're going to be very interested in seeing this comes through, especially it is research, and a lot of the contributors of this group are contributors to your project, so it's going to be really cool. We're 6 minutes over time. So yes, we're going to push our discussion of other work or future collaborations to a February interim that we're going to organize and essentially tell everybody about very soon. I would encourage people to use the list better. But I know right now what's happening everywhere, it's so weird. Nobody has time to do anything, frankly. So our schedules are kind of weird. But anyway, thank you to the top of 88 people who joined at one point. Thank you very much to the other 3 Montrealers who were on the call and who, like me, have days who start in 6 hours and maybe less, actually, if we consider that we have to wake up around 7. For those of you in Europe, have a good day. For those of you in Asia, have a good afternoon. And for people in California, well, it's still feasible,
started.
I guess.
Nearly 11 p.m.
Yeah,
it's
still feasible.
Being here.
Yeah, there was a lot of.
Thank you to all the presenters. And
yes, thank you for all the presenters.
To the continued discussion.
And thank you again for all the people who showed up. And yes, I'm always amazed how fun these things are. So thank you very much. Good night to everybody. And Bangkok time is interesting. Thank you.
Yeah, thank you. Meet you next time.
Bye, Jeffrey.